XAML. We are in the pattern analysis of GATE DA 2026. In this video, we will see linear algebra. Please watch the video till the end. I'll give you some tips and tricks. Okay. To begin with, don't misunderstand that we are solving some problems here. Okay. So getting the answer is not a great thing. So you are dissecting the pattern here. So what is the thing you have to apply? What is that they are testing? So we'll take some examples of previous GATE and then dissect them. When it comes to linear algebra, most questions will be MSQ based. So for linear algebra, you just use this mantra P and P. Properties, practice, properties, practice. There will be no question which will be very lengthy in computations. You need not, they will not ask you to find a big problem and reduce the matrix. No, based on the properties, just you select the correct statements. Most of them will be MSQs only. So understand the properties, solve many problems. So for each of the topics, each of the important properties, I have given the link in the description of my videos. You just revise them and solve few problems. You will be very confident. This one subject will make the difference in your rank, definitely. Linear algebra is actually very easy, but students find it difficult because they go by a procedural approach. Procedural approach may not work in the GATE DA exam because most of the questions in linear algebra will be based on the properties. Okay, and then practice. So then we'll see how actually they frame the questions. If you understand the property, you need to have some practice also. Even understanding property may not be sufficient. We will see them. So mostly it will be around 17 marks with some few questions from machine learning also included in this. This linear algebra is the basis for your machine learning. Any question in machine learning you take will use the linear algebra and calculus concepts and probability concepts only. So I have split up the marks based on the previous patterns. So again, it's a heavyweight subject, around 17 marks, mostly based on properties. Okay. Vector spaces, subspaces, and linear dependence. Matrices, spatial matrices, there are orthogonal, normal, idempotent, and projection. Definitely you'll get questions on this, mostly MSQ questions. Then system of linear equations, rank nullity theorem, and Gaussian elimination, and row echelon forms. So, and then eigenvalues, eigenvectors, and determinant. So this one topic, how many properties you understand and how many practice problems you solve, because this is required for this, and for this. If you observe, most of the questions are based on the concepts of eigenvectors and eigenvalues. Okay, and then again matrix decomposition and quadratic forms. 1 or 2 questions you can expect. They are simple concepts. So the idea is, given any question, you just understand what are the property I have to apply. That comes only based on the practice. So most of the questions will reduce to eigenvectors only or eigenvalues. So if you observe, most of the questions, the solutions will be based on the properties of this. All the properties applies to this also. You'll see in the examples. Okay. So let's dissect one by one. So in vector spaces, subspaces, and linear dependence. So this is the straightforward concept. I have made a special video on this. Okay. So just go through that. I have given the description in the link. So based on the concept definition itself, what is a vector space? What is a subspace? They will ask the question. So what is subspace? You have to understand the definition. What is linear independence and its properties? This is very important. And then you have to understand the concept of span, basis, and dimension consistency. That is the basic understanding for your rank and nullity theorem to solve the system of linear equations. So, and then you check out the properties and then solve many problems. You'll understand what is that exactly they are trying to test you in the exam. So when it comes to eigenvalues and eigenvectors, this is the entire algebra is dependent on this, especially for GATE DA. Most of the questions underlying will be asking you. See, no one will ask you a question, find the eigenvalue or eigenvector. That era is gone. So now in GATE, also in any other GATE mathematics for CSE or any other streams electronics, they will not ask any direct questions in linear algebra based on directly on finding eigenvalues or eigenvectors. So they will ask based on the properties. There are many properties. I summarized everything in my video lectures with examples, and I have solved many problems on them, how they are applied. So you just understand those properties. That is very important, and then you should not only understand, you should be able to apply for new problems. So based on the above two concepts, so they will frame the questions on system of linear equations. See, all the solutions for this basically are coming from your eigenvectors concept and vector spaces concept only, linear dependence and independence. So that you have to understand the properties here. And then a question on definitely on matrices and spatial matrices. Okay, they're basically the properties. There are different types of spatial matrices. I have a separate video lecture for that. I have also pinned it in the description. Please check that out. So identification using defining properties. All things are based basically on properties only. And then one question on matrix decomposition, that is LU decomposition and singular value decomposition. So one question you can definitely expect on this. This is very simple topic. You just go through my video lecture. There are some properties you have to understand and how it works. Again, there is a concept of eigenvectors involved in this also. So let us see and understand the pattern. What is that they are testing you? The questions may look big, there will be a lot of information, but to understand the properties, definitely you can solve them easily. So let us see this question and analyze the pattern. Let R be a set of real numbers. Q be a subspace of R cube. Okay. So R is the set of real numbers that you consider it as a space, and then U is a subspace of R cube. R cube means the real number means 3 elements will be there. That is the meaning. If I write R cube 3 cross 3, it's a matrix, 3 cross 3 matrix. With the matrix corresponding to projection. Okay, this is based on the projection matrix. So once you observe this, you should understand and apply the properties. See, all the questions will be based on the properties. For example, here they have taken the projection matrix and the concept of subspace, how they work together. They actually form the basis for your rank nullity theorem. So which of this following statement is by R true? If U is a one-dimensional subspace of R cube, then the null space of M is one-dimensional subspace. See, what is that? Null space, the rank plus nullity is equal to your number of columns, right? So this is what is the rank nullity theorem. So that means what? The null space of M is one-dimensional subspace. Then if U is one-dimensional subspace of R cube, see, if U is one-dimensional, say dimension of your matrix M is U, is a subspace, then it defines nothing but the rank. This plus this should be equal to 3. When they are saying it's one-dimensional, definitely N is 2. So that means what? This is the null space is not one-dimensional. See, okay. So this is false. Again, this is based on the property rank nullity theorem. How you find the rank? How you find the nullity? So to understand for this the basis, okay, and the span. If you are confused, please check out my video lectures. I have taken different examples step by step. I have made you to understand in my video lectures. I have pinned it in the description. If U is a two-dimensional subspace of R cube, then null space of M is a one-dimensional subspace. Yes, 2 plus 1 is equal to 3. So same thing. So it's true. M square equal to M. See, M is a projection matrix. M is a projection matrix. You know, projection matrix is also a idempotent matrix. That means you square or you take any power of M, will be always equal to M. So that both will be true. So this is directly from the property of the idempotency, the projection matrix. Let x1, x2 up to xn be a set of linearly dependent. Okay, linearly dependent. This is important. Okay, you should understand what linearly independent. Okay, linearly independent. All vectors are linearly independent. Let the I, jth element of the matrix A be given by this. Okay, which one of the following statement is correct? So what they are saying, A of ij equal to xi transpose into xj. So they are basically saying the matrix A is formed using x transpose into x. So where x is this vector. Okay, and all the columns of this vectors are what? Linearly independent. That means what? It has a full rank. All are linearly independent means the rank is full. That means what? So if you know the property of the rank, so null space becomes 0. If null space is 0, then A is definitely invertible. It is not singular. That is the concept here. 0 is a singular value of A. Determinant of A is 0. No, because the full rank matrix. Therefore, there are no dependent columns. So there will be determinant will not be 0. That is, it is not a singular matrix. Definitely, if it is not singular, based on the property of inverse, you know that it is invertible. Z transpose into A into Z equal to 0 for some non-zero Z. Okay. They are saying that transpose into AZ for some non-zero vector Z. Okay, this vector is non-zero. Is it true or false? See, if this has to be happen, this has to be 0. We already know A is invertible. A is invertible because they are linearly independent, having linearly independent columns. Now, so for this to become 0, definitely this has to become 0. So this contradicts the statement, it is non-zero. So hence it is false. So this is how you have to apply the properties. Let A equal to In plus x into x transpose, where In is the identity matrix and x belongs to Rn with x transpose into x equal to 1. Which of the following options is by R correct? The In is the identity matrix. What is that they are saying here? If I take any vector x and then multiply x transpose into x, I should get 1. So you just take n equal to 3 just to verify the options. So I3 is equal to, we get, this is my identity matrix, 3 cross 3 identity matrix. Now you have to choose this x such that I will get x transpose into x equal to 1. So if I choose it 1, 0, 0, this is the only possibility. I'll get this as 1. Okay, then I'll take x transpose into x will be, to take the transpose of this 1, 0, 0, 1, 0, 0. You can also solve this based on the properties of eigenvalues. Okay, if you understood properly, you can solve it. Otherwise, you can just test by doing like this. This will become 1. Now, addition of this means what? A is equal to this plus this 1. This is how you add it, right? All zeros. Okay. Now, this becomes A is equal to 2, 0, 0, 0, 1, 0, and 0, 0, 1. What are the eigenvalues for this matrix, a diagonal matrix? So, eigenvalues will be 2, 1, 1. So, definitely, there is no 0 eigenvalue, hence, the rank of A is 1. Okay. Because it is not further reducible. Rank is n only, n cross n matrix. A is invertible, yes, right? 0 is an eigenvalue of A. No, 0 is not an eigenvalue of A. A inverse has a negative eigenvalues. No. If I take even the inverse, I will not get the negative values. These are the properties. Based on the properties of eigenvalues only, I can find the answers. But if you are confused, just you can check like this. No question will be difficult. Only see, there are only testing your properties and how you apply them. You need not follow my method. Okay. If you understood in your own way, which is correct, you can apply that quickly. Let A belong to R n cross n be such that A cube equal to A. Okay. So A is any matrix such that A cube equal to A. Which of the following is always correct? Always means for every value of A, it should be correct. A is invertible. Is it true or false? If A is a zero matrix, see, just eliminate by options. See, they are saying A can be anything, any matrix. So A, I can take it as zero matrix. Zero matrix is not invertible. This is false. Determinant of AI is 0. The determinant of AI may not be 0. For example, say identity matrix. Identity matrix determinant is not 0. So if A is equal to identity matrix, this is also false. The sum of the diagonal elements of A is 1. Need not be always true. Sum of the diagonal elements for 0 matrix is 0. So just eliminate this. A and A square have the same rank, definitely. So if this is the idempotent matrix, then definitely A and A square will have the same rank. This is the answer. It's based on again the property of the rank. Next, the sum of elements in each row of A is 1. Okay. So then they are giving B equal to A cube minus 2A square plus A. Which one of the following is correct? So you can solve this by applying the properties of eigenvalues also. But in the exam, I told you, if you are not sure of the properties, just try to use zero matrix. If the question use any A matrix or identity matrix and the combination of eigenvalues. You can solve any problems like this based on this three concepts only. Here they are saying this is a matrix. Let us say A is equal to identity matrix. Then you form the matrix using like this. So B will become I cube minus 2 I square plus I. See, I cube is I again minus 2I plus I. What is means B is a zero matrix. Simply you got 2 marks here, right? B is a zero matrix. If B is a zero matrix, that means what? Zero matrix, system of linear equations is X, is B, all zeros, and then equal to homogeneous system 0. That means what? X can take any values. This is, it has infinitely many solutions. It is a simple answer. Now, similarly, based on that properties again, rank nullity theorem and sum of linear equation, that is, you are again given a question based on the properties only. Which of the following is by R true? Multi-select question. There exists M 3 cross 3 matrix such that P belongs to R cube and Q belongs to R3 such that Mx equal to P has a unique solution and Mx equal to Q has a infinitely many solution. Here itself there is a contradiction. If there exists a matrix M, okay, and then there are two vectors P and Q such that Mx equal to P has a unique solution. If this matrix has a unique solution, then infinitely many solution is not possible. So this is wrong, right? So based on that statement only you can eliminate it. You need not take the example also. They are saying this matrix has a unique solution for P. If there has a unique solution, then it cannot have infinitely many solutions. That violates your rank nullity theorem. Again, it's based on the property. There exists M and P and Q such that Mx equal to P has no solutions and Mx equal to Q has infinitely many solutions. Yes, this is true. So for this particular P vector, if there are no solution, doesn't mean that Q may not have infinitely many solutions. Definitely Q has infinitely many solutions. That is true. The both statement becomes independent. No. There exists M and P Q such that Mx equal to P has a unique solution and Q has infinitely many solutions. See, again the same thing. We have changed the order of this matrix, but the first A. Now D. There exists M 3 cross 2 matrix such that Mx equal to P has unique solution and Mx equal to Q has no solution. Again, same as the first one. So it is based on the number of unknowns and the rank nullity theorem. So you have solved many such problems and you know the property. So you just go through my video lectures, you will get it in depth. You have solved many such problems also. So consider 3 cross 3 matrix. The determinant of this matrix is. So this is a straightforward question. Just you need to do some calculation here. Just find the determinant of this M, and then based on the properties of determinant, I can find this. So if you observe here, try to convert it into row echelon form. So if you observe this, if I add these two, should be very careful in the exam. Just add these two rows. Okay, if I do R2 is R3 is R3 minus R1 plus R2. So I will get what? 1, 2, 3, 3, 1, 3. Okay, and then this becomes 0, 0, 0. Okay, so this means what? The determinant will become 0. If you solve this, determinant will become 0. Determinant of M is 0. Then by the property, this will also be 0. Which of the following statement is by R correct? Rn has a unique set of orthonormal basis vectors. Rn does not have a unique set of orthonormal basis vectors. Linearly independent vectors in Rn are orthonormal. Orthonormal vectors in Rn are linearly independent. They are the straightforward properties. They are not twisted anything also. You just check out my video lectures. These are the properties. If it is orthonormal, then they are linearly independent. If they are linearly independent, doesn't mean that they are orthonormal. The reverse is not true. Orthonormal bases are not unique. So what is the basis vector? I explained. So they are straightforward based on the property. So these two are correct answer. Then based on the single value decomposition and quadratic forms. So they are given U, a vector, and let the singular values. So these are sigma 1, sigma 2 are called singular values. I explained in depth what you mean by singular value and what is the use of this decomposition and how it is done. So let they are given M equal to U into U transpose. Where U transpose U is UT is the transpose of U. The value of sum of this. This is a straightforward property for the matrix this of this form, and these are the singular values. The sum of the singular values is given by sum of all this. Okay. So this is nothing but what? The dot product. Or you can write it as the values ui square. Sum of all these they are asking. This will become this. So just check out my video lectures I have given in the description. So this is nothing but 1 square plus 2 square plus 3 square plus 4 square plus 5 square. See here there is nothing calculation here. Only thing is you should know this dot product concept in decomposition, singular value decomposition. So this will come out to be 55. Again, straightforward 2 marks question. Very simple. So this is what they are testing. So if you have seen these questions, definitely properties. Okay, and then to practice these properties on different problem. That's it. So I given many practice problem in my video lecture. Please go through them. First understand the properties. Step by step I have explained the properties in my video lecture. Why and how. Okay. So people only understand how the procedure, but they will fail in the such questions when properties are asked in depth. Okay. So next we will do the pattern analysis of machine learning. That's also a very important subject in the next video. Till then, please like, subscribe and share. We'll continue in the next.